All right. Well, thanks for joining us. We have, well, we're going to start off with the roll call. So let me bring up the page for that. My apologies. Our IT team just reset my computer and I lost all of my bookmarks. So I'm working through that right now. Okay. So is Senator Benjamin Brooks online?
Here.
Delegate Mike Rogers?
Here.
Tyler Abbott?
Here.
Evie Schwartz?
Here.
Josh Kurtz? David Chai?
Here.
Diana Menendez? It looks like Diana raised her hand. Pearl Donahue Valet?
Donahue Valet. Hello.
David Bugelman?
Here.
Stacey Ono?
Stacy Ono here.
Scott Elias?
Here.
And then Bob Sindinsky.
Right here.
All right, so it looks like we have 95% of the members online. So we have a packed set of presentations for you. The first one is Scott Elias from Clean Capital, talking about various different policy approaches. Then we're going to have Bob Nicholson from FCIA talking about a little bit about some of the stuff that they're doing in this space and more of the technical approaches as opposed to the policy approaches. Then we have a really interesting presentation from Neil Vasavada. Is that how you say it?
Vasavada, but it's close enough.
Yeah. From Overdrive Rocks. This presentation may have been better for our next meeting when we were talking about markets, but we already had a pretty packed agenda. But he's going to be going into reuse markets and some of the stuff that their organization is doing. And we had a pre-meeting with him, and it was fascinating and hopeful as well. So without further ado, I'm going to turn it over to Scott and Bob. I think you were going to be doing a joint presentation. Is that correct?
Yeah. So Bradley, I think I don't know if you saw my note this morning. I thought it made sense for Bob's part to go before to cover some of the technical stuff before we go to the policy over the technical stuff. Is that okay? You're on mute.
I'm reading his lips. You said that sounds wonderful, right?
That sounds wonderful. Yeah.
Perfect. Bob, do you want me to share my screen, or you're going to share the presentation?
Why don't you go ahead and share, since you're going to be picking up partway through.
All right. Let's see if I can figure it out on this platform.
For those of you that are sharing, it's next to the smiley face. It's an arrow up. There you go.
You know, I know how to do it on Zoom and Teams, but this one was a new one. All right. Do people see the screen?
We can see your view, like your traditional view of the entire presentation.
Okay. Let me do it.
There you go. Perfect.
All right. I figure, Bob, let's just do a quick intro so people know who we are. But So my name is Scott Elias. I'm the Vice President of Policy and Market Development for Clean Capital. Clean Capital is a investor, owner, operator of solar and storage projects. We have a number of projects in Maryland as well as outside of Maryland, and we do have experience decommissioning some of our projects. And prior, just to give some context on this presentation, prior to my role at Clean Capital, I was the director of Mid-Atlantic State Affairs for SIA. And so one of the fun things I ended up doing a lot was comparing PV recycling policies in different states. And so that will help inform some of what we're going to cover in a little bit. But Bob, I will turn it over to you.
Great, thank you. Can everybody hear me okay? Thumbs up.
Little
Great.
soft spoken, but we can hear you.
Okay, great. Thank you. So as Scott mentioned, my name is Bob Nicholson. I'm the manager of sustainability and PV recycling at the Solar Energy Industry Association. So I've really been focused on end-of-life issues for PV and associated equipment over the past 2 years. So I'll start with just a very quick state of the state. If you go to the next slide, Scott. So just to provide some framework for what we're looking at here in the U.S. currently, there's over 300 million panels currently deployed in the U.S., having a 25 to 30 year life expectancy, in some cases up to 40 years, but generally 25 years to 30 years. The most important point here is that 80% of all the panels deployed were deployed in the last 7 years. So from a recycling perspective, the good news is we feel we're very early in this process. Unlike any other equipment or product in the U.S., we're really, I think the industry is doing a great job getting focused on managing end-of-life issues at a very early stage. So Scott, if you could go to the next slide. So I won't get into a lot of the regulatory discussion because Scott will be covering that, but as many of you know, currently some panels, due to the metals they contain, could be considered hazardous waste under the TCLP rule, but we believe the majority are not. And that's due to the contents of the panel. In some cases contain silver and lead. In the case of thin film panels, they contain some level of cadmium. As Scott will talk about, EPA is considering currently regulating panels as universal waste. And then there's some other state issues happening that Scott will cover. Next slide, Scott. So when I do these presentations, I like to point out very quickly what the current recycling model is or are here in the US. There are really two approaches to recycling. There's what I call the high value model. That's where materials like copper, silver, steel, and aluminum are collected, whether it's steel, structural steel, or aluminum wheels or aluminum cans. In these cases, the value of the material collected exceeds the cost of recovery, which really drives high recycling rates. And in many cases, the generator of the waste actually gets paid for having that material recycled. Next slide, Scott. The second model is what I call the low value model. This is simply materials that the cost to recover the value can exceed the actual value. So materials like electronic displays, mixed plastics, glass, tires, those all fit in this category where there's typically a tipping fee associated with having that material recycled. Next slide, Scott. So again, when we're talking about photovoltaic panels, this is typically a tipping fee business where the recovery of the metals can be more costly than the actual value. Although with capacity increasing now in the US, the cost for recycling is lowering very quickly. And we expect that trend to continue over the next 18 to 24 months. Next slide, Scott. So there's really two methods for recycling that we've seen so far generally. One is mechanical sort and separation, where the panels go into a process where they are mechanically separated. All the components are mechanically separated and taken into downstream markets for recovery. So those are things like the aluminum frame, the glass, the laminate, which contains some of the more valuable metals. Those can all be separated and then taken downstream into new markets. That approach is becoming very common here in the US. I'm seeing a lot of that. The other approach is the thermal approach, basically smelting, where the panels either fully intact or with certain components removed, which is our preference, can then be taken into a smelting operation for metals recovery. And then the glass is used as a flux in that operation and then recovered at times for industrial uses, whether it's abrasive grit or as an aggregate for construction material. Unfortunately, sometimes it's also disposed of as a slag. So we look closely at the end uses for thermal processing. Next slide, Scott. So typical processing line, it's not coming through there, but there now are numerous manufacturers who offer a panel recycling process line kit, if you will, where the system can be installed within about 6 months. And it provides processing of, depending on what modifications an end user uses, it can process 300,000 plus or minus panels per year of full mechanical separation, separating the glass and the laminate, and also separating the back sheet, the junction box, any wiring associated with that, and plastic, and leave ultimately a very clean glass stream from the panel.
And Bob, we can probably follow up with the video that for whatever reason isn't working, right?
Yeah, absolutely.
Great.
Go ahead to the next slide, Scott. So the greatest challenge that we see currently is managing the glass. 80% of the weight of a panel is glass, and it's heavy and it has extremely low value. So it's expensive to move the glass. So our focus right now is helping develop regional markets for end users of the glass recovered in recycling the panels. It's really, the challenge is no different than what I think most municipalities are seeing with their own bottle glass or residential glass collection. It's really a challenge to find decent markets for glass. And I think generally for recyclers, any markets for glass that don't represent a cost to the recycler, I think are good markets. I know there are a number of projects ongoing working on techniques for recovering and reusing the glass. In this slide, I just point out positive, but it's not an endorsement of any kind. It's just to demonstrate that there are companies that are working on end uses for glass. This company in particular is converting the glass to an additive for concrete, not really an aggregate additive, but more of a chemical additive required for concrete. And they have a substantial demand for the material. So it's projects like that that are going to open new markets for the clean glass produced in a panel recycling process, that we think it's important to open more of those markets, find more of those opportunities. And I know of a number of projects ongoing that are looking at creative ways to find end uses for the glass. So we're very encouraged by that going forward. Go ahead, Scott. So very importantly to us is that we feel that the refurbishment and resale market is an important part of the conversation as panels come out of the waste shed, especially those panels that have plenty of working life left, maybe from a repowering project. We're really pushing hard on refurbishment and resale opportunities. Obviously, keeping an eye on the ultimate handling of the panels. We want to make sure that panels, especially those panels that are resold into international markets, are handled properly, because we know that a percentage of panels that come out of the field as working panels ultimately are not. So working with our partners, we want those partners to be very transparent in what end markets they find and how they test the panels. And we're seeing more and more reputable companies with very transparent processes entering the market, the resale and refurbishment market. So we're optimistic about that opportunity and that approach to keeping the panels out of the waste stream. Go ahead, Scott. So a little bit about what we're doing at the association. We have what we call the Recycling Partner Program, where we're developing a list of recycling companies in the U.S. as part of our effort to grow recycling infrastructure for panels. And so what this list really means is, as of today, we have 10 recycling partners on our list. These are companies that have gone through a fairly extensive due diligence process with us. And in that process really includes things like a physical site audit, where I have personally gone to all of our partner sites and reviewed their process. I confirm that they have a process. For those of you, I think Bradley mentioned in the last meeting, history with electronics recycling, where we saw cathode ray tubes end up stockpiled in warehouses. We want to make sure we, as we create our infrastructure, we eliminate the potential for mishandling of products. So we go out and we conduct a physical site audit of all of our recycling partners. We do a regulatory compliance review of our partners. So we look at things like the EPA's Eco Database and state level compliance history. We confirm that our partners have adequate insurance in place. We want to make sure they have pollution liability insurance, as an example, in place before we recommend them as a partner. And we look at a mass balance review for our recyclers. We want to know that they're finding appropriate end markets for their material or appropriate resale markets for working panels. So we recognize in the industry that sham recycling does exist. In our partnership program is designed to ensure we build an infrastructure that provides what I like to say cost-effective, compliant recycling services and refurbishment services. So, and as an organization, as Scott mentioned, we also are working in supporting and developing policy at the state and the federal level. Scott will talk more about that, I think, in the following slides. Go ahead, Scott. So as I mentioned, for our partner program, we have 10 recyclers currently. I expect that number to double over the next 12 months. I'm the primary contact for recyclers at the association. I can say I hear from new recyclers, at least one recycler a week, including international companies that are looking to establish a footprint here in the US. So we're very encouraged by that. We as an organization, we're an ANSI standard, a qualified ANSI standard development organization. We're actually developing 3 standards around end-of-life issues, including a recycling standard that will be an ANSI standard. We're going to back that up with a recycler certification program, which will likely happen in 2025. The next bullet, we do have partners in Arizona and Texas, and we have 2 in Nevada in the queue. I know that's not important to this group, but we've had a lot of attention out in the Southwest, so that's why that's included here. So our current capacity among our recycling partners exceeds 10 million panels per year, annual capacity. I know they're not seeing those numbers yet because it is still very early in the industry, but certainly we expect well over 20 million in capacity over the next year. And we like to point out that one of our association members, First Solar, they They manufacture thin film panels. They actually have a panel take back program. So they're actually taking their panels back. They represent, I believe, less than 4% of all the panels deployed currently, but they do have a take back program. We think that's very encouraging, and we think that that should lead to more manufacturers being involved with their own programs. So we think that'll be helpful going forward as well. So Scott, I think from there, oh, yeah, I can touch base on our national policy framework. We think from a utility scale perspective, the decommissioning plan, decommissioning funding really satisfies any end of and creates a robust system and assurance that end of life panels are managed properly. Certainly, a decommissioning plan can require the recycling or reuse of those panels, so it gives really the local authority an opportunity to have a say. We also think third-party owned and leased solar systems, the decommissioning agreements could live in the PPA and satisfy the end-of-life requirements, including reuse and recycling as part of decommissioning. And then the customer-owned, it's our position that to this extent, customers take responsibility for end-of-life. And as we build out our infrastructure and hopefully increase drop-off locations across the U.S., that should make that much more efficient than it currently is, and to use the existing recycling resources and infrastructure. But we think the industry can continue to do more work developing third-party collectors that can accept these products. I think the electronics recycling industry will continue to grow into the space. I have a lot of conversations with those companies that could become collection points, if not full processors. And we think there's some work to be done between the industry and at the state level to develop resources to identify these locations and collection networks for end-of-life panel owners, whether it's a consumer panel or a retail operation. We think information education is really key focus right now. But any recycling requirements should be forward-looking and phased in, and really consider existing contractual arrangements in industry practices. What we don't want to do is create any policy or procedures that box out future technology that makes the industry more efficient and finds better uses for end-of-life material. And then lastly, I think working collaboratively, states and in our association can continue to collect data to get a true picture of what the potential volumes are and what the current volumes coming out of the wayshed are. I think there's a lot of misinformation when it comes to volumes of the panels currently going to landfill or being collected. We think some more data collection can help really spread the message that the infrastructure we're building is ahead of where we think the volumes are as of today and over the next few years.
Bob, did you see the question from Shannon? If the 10 what is it, 10 million panel annual capacity includes recycling and refurbished, or just recycling?
That's mostly recycling. We do have 2 refurbishers on our list, but their numbers could be much higher. So the 10 million is really focused on end-of-life recycling.
Great. And so this is where we'll sort of shift gears from Bob over to me, although Bob, definitely feel free to chime in because you sort of understand some of the technical components. One thing I want to flag with this national policy framework laid out here, and I think you'll see as we go into what some of the other states are doing, is that commonly a lot of people sort of look at the solar industry as one industry, but obviously there are some real fundamental differences between whether a resident puts solar on their home that they purchase or they lease that system relative to a community solar program or a utility scale solar. And the difference between whether it's the customer owned solar or the non-customer owned solar is something that I think you'll see some states are beginning to look at. Should you treat those differently as you think about end of life? So I'm going to shift gears a little bit here. This is sort of just a highlight of what we're going to cover, but you'll have this deck, so I'm going to just go straight into the actual different state programs and federal programs. So, one thing I wanted to flag here is, before I go too much into detail on this, one thing we've heard a lot of misinformation about is around solar modules. And so one thing, it's probably not news to you that we've seen communities weaponize the concept of solar panel recycling to prevent solar deployment. And that obviously poses a risk for our industry. One thing I do want to flag is that today's solar installations pose little to no risk to human or environmental health at any point in their life cycle. And so claims that PV modules release hazardous chemicals that contaminate our soil or waste stream have largely been disproven. PV modules, as Bob alluded to, are constructed to last 20 to 50 years, and many have test results that characterize them as non-hazardous and contain only trace amounts of heavy metals enclosed in a solid matrix of polymeric and glass material. So the quote-unquote materials of concern are usually only trace amounts, and then those materials of concern are not bioavailable for air or water exposure. And so while it is not encouraged by industry or the National Renewable Energy Lab, there are studies that show that PV modules disposed in a landfill pose very limited risk to human health, even using the most conservative assumptions, and at an order of magnitude less than the limits set by federal law. And I think it's important to mention that because some of the words up here are hazardous, toxic, and I just want to make sure we're putting this in the proper context of what these are and how readily available these types of materials are to sort of communities if they're in their communities. So with that sort of context set, end of life disposal of solar products in the U.S. We don't have a national PV recycling rule, so to speak. And so what that means is the disposal of those products are really governed by the federal solid and hazardous waste regulations, and then the state policies that govern those waste disposal and other dispositions. So when you have an end of life module or discarded solar panel, it becomes solid waste, which is regulated under RECRA subtitle D and through the state and local programs. I'm not specifically familiar with how Maryland treats that, but wanted to flag that. Now, that being said, if those discarded solar panels, they can be regulated under RECRA subtitle C as hazardous waste if and only if it is determined to be hazardous. So what Bob alluded to earlier was this TCLP test. I'm not an expert on it, but what I can tell you is that the toxicity characteristic leaching procedure test is sort of a widely respected test. And if a PV module fails that test, then it will be treated as hazardous. If it does not, generally speaking, unless there are rules that suggest otherwise, it is treated as solid waste. Now, PV solar panels are not currently classified as universal waste, which is a category of hazardous waste under federal law. But I note this because that may change, and I'm going to allude to it in a minute. But some states like California and Hawaii have started to designate solar panels as universal waste. There is an ongoing, I don't know if debate's the right word, but conversation in policy circles around whether designating end-of-life hazardous PV panels as universal waste would actually help improve management practices and encourage recycling by allowing for mass collection. And so that is, sort of one thesis, is that could be a good thing. Now, I mentioned this because in November of last year, the US EPA announced that it is going to be developing a proposed rule, which they say will come out around the summer of 2025, but you never know when those types of things will really come out. But that proposed rule will do two things. In theory, it will modify the existing universal waste requirements under the RECRA Act for lithium batteries, and it will expand the universal waste rule to cover waste of solar panels. So we don't know the details of that, but one thing this commission and the state should keep in mind is that the sort of federal regulatory apparatus around whether to treat this as universal waste or not may look different come summer, September of 2025 as well. The other thing I will flag, mainly more as a preview for, I believe it's next session, is that someone I think from DOE is going to come to talk a little bit about the action plan for PV system end-of-life management. But at a high level, all I'll say is that DOE has done a ton of research on this, and they think that PV volumes may reach 12% of US annual municipal electronic waste volumes in 2050. which sounds obviously like a large number, but is also 0.1% of US total solid waste volume. Their strategy is intended to have the cost of recycling and reduce the environmental impact of end-of-life PV. And as you will sort of hear, and Bob sort of alluded to, today it is more expensive to recycle PV modules relative to where it should be in 2030, 2040, 2050, when there are a lot more modules that are at their end of their life. A lot of the modules that are out there are going to be continuing to operating for a long time. And so while our company has decommissioned some projects, there are plenty of companies out there that have not yet done so. And so the cost profile of recycling will change as a result of initiatives from the federal government, as well as some of the initiatives that SEIA has sort of laid out previously. I see some questions. Some farmers believe their property losses. I am familiar with rumors around that. SEIA may have studies that can talk about property loss or property value gains, but I don't have that readily available. And I'm not sure I understand the second question, but maybe we can come back to that.
Scott, I can touch on the second question regarding regional processing facilities. We haven't seen, or nor do we see the need for regional processing facilities for a couple of reasons. One, we're seeing more and more facilities enter the space. Again, we've got processing capacity across the bottom half of the United States. We started working our way up the eastern seaboard. I think we have now processing capacity up into the Carolinas, and I'm working with a handful of recyclers going as far north as Massachusetts. So we're seeing the capacity grow very quickly and have great geographical reach. The area of focus really from a geographical perspective is in collections. So if there's going to be any work done, from a regional perspective, we'd like to see regional collections and let the existing recycling companies continue to grow and enter the space and provide processing capability.
Great. And I'll move forward, but yeah, thanks, Steve. So this is just a high level. I want to make sure folks have some of the resources. So NREL, as I think most of you know, the National Renewable Energy Lab is a very reputable lab. They have a ton of resources on everything from PV recycling to PV recycling policy to decommissioning policy. And so this is sort of just want to link to those resources, but sort of at a high level of who sort of started to deal with this issue. We're going to talk a little bit about what California and Washington are doing. We're going to talk a little bit about what North Carolina did. We're going to talk a little bit about what New Jersey and New York are doing. And then there's a lot of states that are sort of exploring this, having sort of convenings kind of like this. I know Minnesota and Illinois don't have really, to my knowledge, real structural commissions, but are sort of looking at these issues. And I think this is a hot topic that a lot of states are looking into. So there's a couple different themes that we will see that sort of come out, which is, how do you best do this? And is the onus of responsibility, on the manufacturers or not? And we're going to talk about that in the context of what is called an extended producer responsibility model in a second here. Yes, Senator Brooks.
Yes, Scott, Senator Brooks. Yeah, you said about 80% of the makeup of a panel, a PV panel, is glass. And it seems like glass would be an easy recyclable component, so really that leaves 20% for us to really probably try to recapture metals, silicon and whatnot. And then 80%, if that 80% of it can be recycled, then that seemed like the problem wouldn't be as great as we think it would be. Am I wrong in assuming that?
So I'll let Bob cover the technical side in that in a second. I think the question right now is less can things be recycled and more what is the cost. And so right now it is true that it is cheaper to landfill or sell a product as a resale than it is to actually recycle. There is a cost to recycle right now. But Bob, do you want to take the sort of technical part of the 80%, 20% stuff?
Yeah, so yes, indeed, 80% of the panel by weight is just glass. It's borosilicate glass, which is very common. And there are channels for recycling glass across the US. The challenge is right now, it's just recycling glass is costly. I think every municipality in the country deals with that. That it's not a situation where, as a recycler, you get paid for the glass. That's what we're working on now. We're working on helping companies create new markets for recovered glass that brings more value, which in turn will drive recycling costs down. The goal being to get recycling costs as close to landfill costs as we possibly can.
I see. Okay. And let me throw this out with glass. I think I'm originally from South Carolina, and I think I saw one time where they were taking glass and combining it with and putting it in asphalt and using it to pave roads with. So it adds additional durability to it. So I don't know if that's something that we would consider.
Yeah,
Well,
we absolutely have seen that.
yes. Okay. Thanks.
I would just add, it is something that we certainly can get rid of, but people aren't really interested in paying a premium for it. So then that kind of makes that market just a little bit tougher to tackle.
I see. Thanks. Thanks very much.
And I do just want to point out, bring some numbers in our glass recycling. In our last report, we reported that there was about 141,000 tons of glass that was recycled in the state of Maryland, which is pretty good. And just your comment on adding glass to concrete, that's they mentioned the company Positive, or that's a product. It's actually a different company. That's exactly what they're doing, and they're actually interested in Maryland. My recycling team has been tasked to implement HB 164, which has to do about bringing recycling markets to the state of Maryland, and they're actually in conversation with that gentleman, just trying to help him through the process. He's also looking for some grant money as well to help reduce some of the financial burden of setting up a recycling operation.
Great. All right, I'm gonna dive in now into some of these states, and feel free to keep asking questions as we go. So California, I thought would be a good one to start with. So California's Department of Toxic Substances and Control began regulating PV panels, end-of-life PV panels, as universal waste in January of 2021. I'm not going to go into detail, but these are a couple slides of like what specifically are they doing, what are they authorized to do. The New Jersey Commission sort of studied this and said it's a little too early to see if this process was a success or not. What I can tell you is that the California regulations do assume that all end-of-life solar panels are universal waste unless the panels are determined to be non-hazardous based on testing manufacturers' information. But California is actually in a very interesting space where their legislature is actually right now discussing two potential bills. And one of the scenarios that has happened is, because they are treating end-of-life PV panels as universal waste, which is meant for a subset of hazardous waste, there have been financial burdens for setting up PV recycling facilities in the state of California. And so some legislators, seeing that, wanted to actually create legislation that would seek to ease that financial burden and encourage more of the recyclers to open up in California. And so they're proposing to require that the department create alternative management standards for the management of PV modules instead of managing those PV modules as hazardous waste. Complementary to that is sort of this other bill. The two bills may get combined, and we still don't know exactly the fate of what's going to happen with this legislative session there. But the bill is also looking at how do we find the right way to ensure all PV modules in California have a specific end-of-life management plan that describes specifically how the solar PV modules, whether they are on someone's home or whether they're in sort of the more desert area, how each of those will be managed at their end of their useful life, with a specific plan for who is responsible for managing them, how they will be recycled, refurbished, or reused. And so I know that Bob's team is very engaged in that, and so we could certainly follow up with more information about the specifics of what sort of the industry has proposed, as well as what others have proposed there. But wanted to flag that as because this is, I think, one of the more pronounced examples of where some states are looking at treating customer-owned versus non-customer-owned differently and having sort of different structures for that. The next state I want to give a high-level overview of is Washington State. Washington State is a state that is highly pointed towards because they did something unique. But doing something unique does not necessarily mean that it is completely beneficial. So what they have done is they have created a Washington State PV module stewardship and take-back program. This created a requirement which requires PV module manufacturers to basically be the ones responsible for financing and implementing a take-back or recycling or reuse stewardship plan for PV modules sold after a certain date. And so beginning July 1st, 2023, no manufacturer, distributor, retailer, installer could use modules within the state unless the manufacturer had submitted and obtained approval for a stewardship plan from the Washington Department of Ecology. Now, I am not a complete expert on all the details of it, but what I will tell you anecdotally from the industry's perspective is that this has created uncertainty and liability for solar module manufacturers. And in general, this extended producer responsibility model in the eyes of some of the industry leads to unknown costs that are then passed down the value chain and ultimately to consumers, which could raise the price of solar and of course, make it more difficult to reach clean energy goals. We do know, and Bob can probably speak to this more than I can, that there are some manufacturers that are either considering or that have declined to make future sales in the state. And so this is, I think it is highly touted because it's the first state to do this, but it is certainly one that I think there's not consensus about whether this is the right approach for a state to take. Bob, do you have anything you want to add more on that? I'm going to talk about Niagara County in a second because it's a good parallel. Okay.
No, I think you covered that pretty well.
Shifting gears to New York because it's sort of a similar story, and I can kind of speak a little bit more into detail on this. Niagara County did a very similar thing. They became the first local government in the nation to pass a local law, can't speak today, requiring that producers finance those solar panel recycling options, right? So you cannot do a project in New York unless the manufacturer has a plan that demonstrates sort of full compliance. There is an alternative where you can kind of have a stewardship organization acting on behalf of the manufacturer. But this law has been in place for 3 years, and there is only one manufacturer with an approved plan in Niagara County, and that manufacturer is actually no longer in the solar business. There are some plans that are pending from the stewardship organizations, but the reality of what this has done is it has resulted in many canceled or halted projects in Niagara County because obviously if you don't have a manufacturer on the approved list, you can't do work there. And this has created concerns in New York that municipalities can weaponize this issue to prevent solar or energy storage deployment. In response to that, the industry is proactively working with the legislature and the governor to make improvements to solar PV recycling without impeding progress towards its clean energy goals. One of the things they want to do is very similar to what we are doing here. They're initiating, or they want to initiate, a statewide PV recycling assessment with recommendations for a statewide program. And they also want to preempt local laws related to PV recycling until that study is complete and a statewide plan is in place so that counties don't put up more barriers. One of the interesting things they are doing that we're going to talk a little bit more about when we get to New Jersey is they are also looking at creating a tax credit program to encourage solar panel recycling companies in the state of New York. And that's something that Maryland may be interested in doing as well. And really, instead of this extended producer responsibility model, there's this idea of supporting waste management strategies that leverage existing practices, such as decommissioning plans through the non-customer owned type of solar. So for instance, the types of project, like honestly, the project behind me, which is actually for the PPA for Howard County, typically what developers do is in their land lease agreements, even if they're not required, will often have decommissioning provisions that lay out, obviously the removal of the structures, but often what they're going to do with those at the end of their useful life as well. New Jersey, and I have hyperlinks because, with the amount of time here, we're obviously not going to go into the full detail of everything, but I want to give you sort of the picture of the themes of what they're doing. New Jersey in 2019 created a New Jersey Solar Panel Recycling Commission to effectively do what we're doing. They released the report at the end of last year. They sort of came out of their report with two core goals. One is recycling end-of-life solar panels and sending the components to obviously legitimate recycling, because an eventual goal of recycling 100% of the components, even if that's not a near-term objective perhaps. And goal number 2 is actually extend and use and reuse the solar panels. Just because you have a PPA for 20 years doesn't mean that the solar module is going to stop being able to be productive after those 20 years. And so their recommendations really centered around 4 core recommendations. One was encouraging and incentivizing the construction of PV recycling in New Jersey. They didn't have necessarily a definitive, this is what we should do, but they laid out a number of different options between 10-year tax abatements, which is a little bit similar to what New York's thinking about, offsetting, the cost of equipment, performance rebates, and I'm sure there's a number of different tools that Maryland could use if they wanted to replicate that approach. The other thing that they are doing is recommending that they manage PV solar panels as universal waste at existing facilities. They are considering a landfill ban on disposal of end of life in New Jersey. They are considering 2 sort of approaches coupled with the universal waste laws. One is to create an advanced recovery fee per panel at the time of purchase by the consumers, but they are also looking at an extended producer responsibility program for PV in which the recyclers would be able to charge manufacturers or importers for each panel recycled. The details of that are not yet fleshed out. There is sort of going to be more work on this in the future, and it may make sense for this group to cover closely what that group ultimately does. The other 2 sort of goals, continued use of solar panels beyond nominal or arbitrary determined lifespan. I think this is particularly relevant. In Maryland, there was conversations around, in the net metering working group around community solar and what does decommissioned mean, and should we put an arbitrary, time frame on it? And New Jersey is sort of going the opposite way and saying, well, you should go really as long as you can go, and that can often be by sending those to the secondary market, or sometimes different organizations will sort of donate panels to different charity organizations to use really for free, because they can still sort of produce. And so those are sort of the 2 core ways that New Jersey is looking at the extended use and reuse of those solar panels. North Carolina, they in 2019 had a bill that told them to look at whether to develop regulations for really utility scale solar and wind and how to manage end of life equipment like solar and battery storage. They released their final report in January of 2021. They, similar to what we just saw in New Jersey, established the following order of preference for management of retired and end of life modules: direct reuse, obviously, if it still can generate power; refurbishment, repair for reuse; recycling as a 3rd option if you can't do reuse or repair, if that's not feasible; and then 4, ultimately disposal. And I think that's a theme that you sort of saw with what Bob had referenced, and I think we're starting to see. It's not just thinking about recycling the panel; it's thinking about what can you do before you get to the stage where you would need to actually recycle it. They, similar to what we discussed before, they determined that PV modules that exhibit hazardous characteristics by failing a TLCP test would be managed as hazardous waste, but that non-hazardous PV modules, those that don't fail that, would be managed as solid waste. They did determine that PV recycling opportunities are limited and costly. Now, I will note that the cost trajectory has changed somewhat from when this came out, because there are more options now, but as they've indicated, costs should come down as more modules do reach their end of life. And then their section, they did have a lot more on sort of the infrastructure that would be needed for the collection and transport of end-of-life PV modules. And I know that Bob's boss was actually involved in some of those conversations, so I'm sure they could follow up on more details about the logistical side of it. And then finally, I do want to point out they did not recommend a manufacturer stewardship program in that final report, but did note that they would consider it in the future. And then the last state that I was going to go over, and this is not necessarily completely recycling, but I want to reference it because it's within the scope of A, a conversation that's been a hot topic in Maryland, but B, because it's sort of tangentially related, and that is around sort of decommissioning. And so Texas passed a law in 2021 that has sort of been widely cited as sort of an example of what often actually is now industry best practices anyway. But they required that solar developers and landowners include specific provisions describing the developer's responsibility to remove project facilities from the landowner's property at the end of its useful life. And so one of the ways to do this, and where this relates to sort of the way California was looking at this, is well, solar developers that are the long-term owner operator of a project, a company like mine or a company like some of the others that are operating within Maryland, they may not need to participate in the types of program that Washington is proposing, because what we are effectively doing is creating a rainy day fund through decommissioning agreements and decommissioning financial assurance that will ultimately be used to cover the cost of what we're going to do at the end of the useful life. And so in Texas, it's required that the amount of financial assurance sort of be calculated by a third-party professional engineer, and that there are specific ways that you demonstrate that financial assurance. And ultimately, I think what we will see the industry move more towards is also specifying within those agreements how you plan to use those modules at the end of its life, and likely things like saying that we will reuse, repurpose, refurbish, or then ultimately recycle and or not put it in a landfill, things like that. So that is the end of my presentation, but I will see if anyone has any questions for me. All
I
right,
can
back
see
to you,
the wheel
Bradley.
turning. Yeah, well, thank you for that presentation. We are actually, just to touch on some of the things that you talked about in your presentation, we're actually at our next meeting, we're going to have someone from EPA who is actually working on the universal waste rule, I think is what EPA called it at this point in the life cycle. Giving a presentation. They're also going to be talking about, or they're going to be doing some forecasting as well, models, and those forecasting models are regional, and it's based off of various, like when we expect to see the wave of when solar panels when the infrastructure needs to be put in place. So that can be used as a really interesting planning tool for this. The good news is we do have some time, but that time will be here before we know it. So if you can join us in our next meeting, I think it's going to be a fascinating discussion on that. And just to answer, yes, the slides will be available. We will also be posting these slides on our website as well. Okay, our next presentation is Neil with Overdrive Rocks. And again, this is going to be focusing mostly on the reuse markets. So when we think about reduce, reuse, recycle, you're actually supposed to reuse before you recycle. Although Neil may touch a little bit on this, but I think there's definitely some opportunities if we start to reuse solar panels. They may not be the most efficient, but there could definitely be some implications for bringing in lower cost renewable energy into EJ communities as well. Without further ado, I'm gonna have start the presentation. Sorry about that.
Thank you all. I hope you all find this useful, because this is outside of, I think, how solar reuse, recycling, and everything is thought of oftentimes. But bear with me, because the more I heard y'all speaking in the first conversation, the more relevance I see. I want to tell you a little bit about what we do first and where we came up with the perspective here. And our perspective is very, very different than I think what you guys will see in the regulatory space, or even the commercial residential solar space. So first of all, our mission. So our perspective is all about reducing the use of fossil fuels in live events. And that means that we look at PV, we look at solar as one of many tools to accomplish this. Our viewpoint is very, very different. And the longer we've been in business, the more we find that we don't have a whole lot in common with commercial and residential solar or municipal and a lot of this. But I think that there are lessons to be learned there. I don't want to go over our bios, but I do want to speak very quickly about where we came to our perspective. So I have a background in renewable energy, as does one of my business partners, Sean Jacobs. We are both engineers by training, and I worked in the automotive industry in hybrid electric vehicles and electric vehicles for quite a bit of time in my career. So I'm not a stranger to regulations and policy and trying to figure out, how to meet them. A lot of these slides are taken from sort of our decks where we're trying to educate people, and so I'm not gonna be sticking to the slides so strongly. I've made some notes here which I want to bring up with you. One thing that fascinates me about this conversation is, why are we even having it? In our experience, and from what I know, is that degradation rates are low. They're actually lower in the field than we've been quoted, and we're seeing, even less degradation in commercial and other applications. I can't speak to the cost, but I wonder, hearing this conversation, if assessment, management, and redistribution would have cost advantages to recycling. I mean, solar is fundamentally an asset that's super simple and very, very adaptable. And you can really expand this to battery storage and inverters. They're highly durable, they're highly usable. And so from my perspective, and understanding that I do not have exposure to the issues and everything that this group is dealing with, but from my perspective, this entire end of life topic is strange. I feel like we should look harder at the definition of the end of life before all of these resources are put into developing recycle schemes for a product that, from we see, is going to be in place for 20, 25 years before there's any real need to remove it. And even at that point in time, is recycling or disposal the best place to go with this? Now, I also want to have make a point on misinformation. So I represent the live events business in the sustainability space. I am one of the founding members of Musicians United for Sustainable Events, which is an East Coast organization that deals with a lot of boots on the ground, people in our industry trying to be more sustainable. And also from the other end, I'm one of the founding members of what's called the Music Sustainability Alliance. And this is an industry trade group made up by the largest concert promoters in the world about sustainability issues. So I have a little bit of perspective on that, and I deal with misinformation quite a bit. I speak at conferences in the entertainment, sustainability, and waste management spaces. And one thing I'll say, which may sound odd to this group, but I think it's important that all of us in sustainability start to understand this, that this is more of a cultural issue than it is a technological issue. We're putting a lot of effort into using technology to solve a cultural issue. And that's something that the live events industry does well. We may not seem like an intuitive partner to something like this, but what we do is we provide highly visible, well-managed examples of the implementation of these technologies. We iterate. We have the same sort of thing we're doing over and over again in a closed system. So we generate a lot of data, to back this up. And this isn't my first rodeo with assets that we develop in live entertainment, managing these things, and then move it to a larger world. I used to do flooring and crowd control and things like that. The assets that we developed in the live entertainment spaces now are now used in disaster relief. They're used in construction. They're used in the military. They're used in a lot of other places. So I'm going to say that this focus on recycling and conversations strike me as a little burdensome and as an impediment to efficient development. From my perspective, we're solving for an issue that's actually easily manageable. So with that, now that I've thrown all that out at y'all, a little bit of where I'm coming from, just to give you all an idea of our credentials. In 2023, 2.6 megawatts might seem like a tiny, tiny number to y'all, but this is the largest amount of renewable energy deployment the live events industry has ever seen. And in 2024, we're already close to 10 megawatt hours. We are coming into places. We're deploying solar very quickly. We're deploying sustainable energy systems very quickly. We're using them and we're pulling them out. It's a very, very, very different use case than most of the world sees. But here's what's interesting is that it has become apparent that this is a more cost-effective and reliable way of providing energy than a lot of the existing, methods, mostly diesel generators in our business, but even grid power. And I want to share with you all why this is the case, and maybe just plant the seed to see if we can look at end of life differently. Okay, one of the first things, and again, no need to go into huge detail with these slides, but is modularity. When we are designing energy systems using PV, they scale very easily and very efficiently. So when you're talking end of life, when you're looking at all these panels that may have 10, to maybe 15% degradation, is that even an issue when we're dealing with a modular infrastructure? When we're dealing with something where you just add more or less, is adding 10% to a 25-year-old asset that's been working for 25 years in order to get it right back to that new performance that big of a deal? Is that harder than everything required to, essentially disassemble and reuse all those components? Another thing is energy aggregation and how these work. Again, we have multiple power sources that we can use and store energy. This is not really news to anyone in the renewables business, but when you have solar and grid power and other sources, and we can store them, what does that do to the value of these panels? All of a sudden, it seems like even a 25-year-old maximum degraded panel has a lot of value, a lot of potential to be still used generating power. If a bunch of roadies who have engineering backgrounds, but we joke and say that we were such bad at engineering that they made us do rock and roll instead. And if we can quickly come up to speed and lead a very, very visible industry in renewable energy with these assets, you got to ask yourself, are these assets that complicated? We talked about this. I've been kind of saying the same thing, but the big thing I want to point out is we have a lot of flexibility and we have a lot of potential resilience that comes from PV. And my thought is focusing on disposal and recycling is leaving a lot on the table, because that flexibility can be used for a lot of different things. We're talking very high level at dealing with food deserts, and also dealing with underserved communities and areas where it's difficult to get portable power. And we're using stuff that was never designed or intended for this purpose at all, right? I mean, no one who designed a solar panel thought that it was going to be loaded onto trucks and go on rock and roll tours. No one that designed inverters or batteries thought that they would be used on the ground at Bonnaroo and Lollapalooza and all these big events. By the way, as an aside, I forgot to introduce myself and say that I started in the business in DC. So I did the presidential inauguration in, I think, 2012, 2008. We did stuff for Folk Life on the National Mall. We did a huge concert with HBO called the Concert for Valor in DC. A lot of events in Maryland and Virginia. I did a lot of stuff at the Raven Stadium. So I've seen the situation on the ground, the boots on the ground, how even in your area, how easily we can get these assets deployed. Here's a perspective for y'all, especially those of you who have a background in commercial or municipal or large solar installations. When we reimagined how solar is done, what we did for the rock and roll industry is we looked at, okay, how do we minimize transport logistics? How do we deploy it quickly? We're moving into a place we have very little time to get stuff up and running, and then tear it down and move it to the next spot. And we found we can get 240 kilowatts of solar in a truck and set it up and tear it down in 4 hours. So in 4 hours, we can build temporary 240 kilowatt solar fields out of just one truckload of gear. And frankly, we're looking at at increasing that to 580 by double stacking stuff. You know, this is stuff that's wind rated. This is stuff, again, that that wasn't designed for this purpose. But if we're using it for that purpose, I ask again, is reuse potentially a much more competitive, compelling use than recycling or otherwise? And, you know, I'm just going to throw out a couple other things that we have in conversation all the time with people from more traditional solar installations. It's incredible to me how the rules that we're told don't really apply as we get more and more into these things. First of all, matched panels, you know, I can't tell you how often we have had stacks of things that are not the same, and you have to make it work. And it turns out that a workflow which looks at similar panels, strings, how they're configured and everything is not that difficult. And we've been able to take assets that are at venues and locations that we get and build them together in relatively short time to get the output we need. So we already see a lot of panels on the secondary market because they're overstock or overflow. I mean, before we start about recycling, I don't know how much visibility people have to how many new panels are available. In fact, Overdrive rarely buys new panels because there's so many, I don't know what the technical term is, cast-offs or whatever they are from installations that didn't use entire pallets. These work really well. Again, degradation, I think I've said enough about it. This doesn't matter. It just doesn't. We don't see significant amounts of degradation. Balancers, sorry, spelled wrong, microinverters, things like that, things that are very common in commercial residential. When you're just trying to get the asset to make it power, a lot of this doesn't work. So what does this do? All of these things drive the price down considerably. The logistics can be driven down considerably. All of the costs associated with deploying solar comes down considerably. And now again, have to ask yourself again, you know, what's the ROI on that? And really, should we be focusing on recycling and disposing these panels ahead of repurposing? Now, I'm not saying that there's not a strong need for that. I actually don't know. I don't know how much this group, you know, deals with policy or anything, but from my very, very outside perspective, but as somebody who is using a lot of PV and deploying them in a wide variety of situations, it seems to me that we have a lot of opportunity to repurpose solar and to bring energy to, might I say, democratize energy production at a very low cost by focusing on repurposing. So, you know, the last thing I'll say is that, you know, I mentioned to y'all, misinformation is a big part of what we have to deal with, and I think everyone in the industry has to deal with. So we have done one other thing, which is we're very, very big on sharing what we do and being transparent about it in case studies, sharing data and things like that. You know, we very, very much deal with this information by pointing out this works. All right, there are 100,000 people who are sitting in Grant Park in Chicago watching that Billie Eilish show that cannot deny that it works. It did the job. And then if people want to know more, we've worked with Oxford University and we've worked with people from JPL NASA to produce third-party case studies that show the efficacy of these systems when they're not in the ideal commercial residential sort of application. And I think that that information that we're doing, the work that we've done, I think can also support the assertion that reuse and developing a robust way to deal with panels when they are, for whatever reason, removed from where they were working is a very compelling solution to Second Life panels. And I think that's about all I have to say.
Yeah, thank you very much. I had just a quick question. When you're looking at some of these secondary markets, and my apologies if you mentioned it, but what's the dollars per watt that you're finding, or some equivalent cost?
Realistically, free. I mean, there are people. I I find the disconnect between boots on the ground stuff sometimes pretty fascinating. There are people who have got that have got large stocks of panels that are recent takeoffs and things like that that are just trying to get rid of them. And all you have to do, if you don't believe me, is go on Craigslist in any urban area around here, and you will find warehouses where people are selling, I mean, they're selling them for 10 cents a watt or less, and these are brand new panels. Oftentimes, well, I'll give you a real good example. Footprint Project. That's a great organization. Y'all should actually look it up, footprintproject.org. They do disaster relief work. They're a nonprofit that uses sustainable energy systems for disaster relief. They have supported a lot of the hurricane activity in the Southeast, wildfires out here in California. The founder, Will Heegard, is an amazing person. He's a friend of mine. They are swimming in solar panels. They don't know what to do with them. They get so many of them donated to them at this point that Will and I are always trying to work out a scheme how he can get his donated solar panels out there working in other applications, because he can't take money for them, but he's running out of places to store them. I don't know how aware people in your guys' space are of these realities on the ground, but from my perspective, there's a lot of underutilized solar as it is, and a focus on recycling seems to me a little strange when we have this opportunity to utilize things that are there already. Now, granted, I'm not an example on it. I'm by no means an expert on the subject, so there's a lot I don't know about why people choose to recycle instead of reuse. But this is all speaking from my experience.
And just I actually recently just got solar, and our price point was $3.40 per watt, which is pretty good for new solar panels, but free is always better. Although I could not install them myself. We have a question.
I assume that cost.
What was that?
I would assume that cost is the full system, not the raw panel. And I'm just talking about the raw panel, which we typically see wholesale is 50 cents a watt for the kind of stuff we use.
So you are correct. That was for installation and the cost of the panels as well. John Miller, you had a question?
Hi, yeah, this is John Miller from Chaberton. Just wondering, in a situation like that where you're utilizing older solar panels or different solar panels for projects like this, I mean, what role, I guess, would you envision the state having in facilitating this, especially on a larger scale? It seems like right now it's on a very small scale, so I guess the focus would be on how do you supercharge this so you create that pipeline down the road?
I would like to see, well, first of all, from my own perspective, it would be interesting to see numbers on what people are expecting for panel removal, let's call it, so to understand the scale. And then I would only say, I haven't heard if there's also a focus on reuse, but I have heard in this meeting all about all the effort and energy that's going into recycling. And so my first thing would be, from a state level, from a national level, from a regulatory level, could we have the same focus on reuse and redistribution? Does it make sense to? Or is there something I don't know? Let me turn around and ask that to this group, actually. When you are hearing all these conversations and you guys are dealing with the regulatory stuff over disposal of panels, is there an equal amount of energy or attention going into reuse?
This is Scott from Clean Capital. I would say I think it depends on different states of what they're doing. I mean, I think the law that created this commission is requiring us to look at recycling in part, but I think as we've seen from what North Carolina suggested and what New Jersey has suggested, there is an emphasis on reuse, refurbish before we get to recycle.
And I was just going to add in that, this work group is not, I guess, we need to certainly adjust the name of the calendar invite, because this is not just the solar recycling work group. Our task is to look at all parts of just that end of life as well. Oh,
Yeah.
David.
Oh, I don't know if your audio is working, David.
Can you hear me now?
Yep.
Yeah.
Hi, my name is David Comas. I'm with the Maryland Energy Administration. I'm working with University of Maryland Global Campus, and one of the concerns that has been brought up is the large damage rate that occurs when you decommission arrays. And so one of the thoughts was the requirement to go train workers to not damage array panels as they come off the line, plus the damage that occurs during transportation. You obviously have a business where damage of setting up and taking down and transporting is very small. What do you do? Do you have special training for your people, and do you have special containers for transportation of these reused systems?
Hey, David, that's a very good question. And it's a good question because it's something that I've been asked before. So it's actually not that complicated. Yes, it's when you look at the solar transport industry, the entire industry is built around how can we cheaply get panels from point A to point B once. That's why often we see them banded in cardboard. What we designed is stillages where panels can sit vertically, and then they're clamped together. There's not really a lot of retraining for the workers. What we do is, we favor using mounts in our operation that don't require fasteners and tools. Everything's clipped. It still has wind ratings and things like that. So when they're in use, in our use case, they're very easy to install and remove. When they're transported, we don't have an issue, and it's a very, very simple design change. There's a company called PV Pallet that's sort of doing it as well. They're interesting to look at. But I would say that one observation from those of us who work in the field with these is they're a lot more durable than we expected. I mean, the glass is rated for hail use and things like that. I can't tell you how many times a C wrench, what we call a combination wrench, falls off of someone's belt or something like that onto a panel. And I think we've lost 5 panels out of our stock of nearly 600 this year, and almost all of them is from like someone backing a truck into a solar array, which is what happened at Luck Reunion this year. So, I think that damage coming on and off is a problem that's easily mitigated. It's sure, maybe a little training, but not a huge cost. It's just a difference in practices from people who are used to only going in one direction, right? Which is bringing them to the site.
The PV pallet is a fairly expensive option. Did you custom design your transportation system, and is it expensive?
Yes and yes, but it doesn't need to be expensive. We have the luxury of building things to a very high level because of what we're doing and how we're doing it. I don't think that the average PV customer is going to be moving panels every 3 days in trucks. And, let's be clear, the people who the labor we're using is not skilled labor. They're just local stagehands. They carry things. Whereas I think the cost in our example is certainly high. It's also not one of our big design criteria. And I think that if someone was to look at that and apply those practices to something that's designed to be cost effective, you're going to see the cost go way down. And then the second thing is that from what I've seen, most solar transport solutions are disposable. Now, maybe I haven't had visibility to this, but I can't believe that over the life of a custom stillage, even ours, if ours are, and I fully believe that ours could be used for 20-25 years, they're fairly simple and very robust. Is the lifetime cost of these things any more than the current practices?
Okay, thank you.
All right, I think Senator Benjamin Brooks was next, and then Abby. And you are muted.
Sorry. Okay, yes, I'll start again. Neil, thanks for the presentation. Yeah, I think it was your fifth panel where you were talking about the proven technology, and you had there's an example of the sun hitting the panel and then going directly to the battery storage, and then it goes to the inverter, and then out to wherever. So this is primarily a commercial application, right? This or is it?
Well, I would say that's an example, Senator. And one of the neat things is that, remember the flexibility I was talking about?
Uh-huh.
It's the PV can be used in so many ways. For some of you more technically oriented, so we have done installations where the solar panel is used to charge a battery, and Senator Brooks, I think that's what you're thinking about here. But we've also done applications where we have a large battery storage system and a grid-tied PV system that is in front of the battery storage system, where it supplies the load directly for efficiency purposes, and any solar production up and above the necessary load is stored in batteries.
Okay, great. That's what
From a technical point of view, what I'm saying, Senator Brooks, is we can actually, one of the cool things about PV is you can layer it in so many different ways, and that just enhances the reuse potential, the way I see it. There are so many different ways that we can structure it for efficiency, for cost, for ease of installation. And we do this all the time, because when we install solar, we show up someplace with very little in terms of plan. We've got 24 to 48 hours to figure out where to put it down, how to get compliance from building inspectors and fire marshals, and it has to be effective, because the data is something that we're transparent with, right? So if I do an installation, and we just did one at the Pomona Fairplex 2 weeks ago, where we put them on office trailers. If I do an installation, it has to be effective, and it has to happen in a short amount of time. How many other power generation assets are that flexible?
right.
And again, that's my argument for why throw it away when it's such a great tool.
Right, yeah, because when I was looking at it, I knew, of course, I've got solar panels at home, and then we got the panels, those electrons go to the inverter, and then we use it in the house, and any excess goes to the batteries. But I see what you're saying. You've got the flexibility to do it many ways, so that you can utilize it in whatever need that you have. Well, thanks very much.
Thank you. And for some of you a little more technically oriented here, we're even doing things like using MPPT controls with direct DC controllers to go direct DC, because a lot of site lighting and things like that is natively 48 volts DC. So when we bypass a power supply, now we're 20% more efficient. And this is a great example of cost reduction. By eliminating an inverter and using solar and direct DC, we were able to cut site lighting costs for Coachella by 50%. This is after already a 25% reduction in their site lighting costs when they went from generators, which they had to fuel constantly, to battery storage systems. So I know, again, this is a very small use case, a very small example, and may not scale or be applicable to what y'all do, but the flexibility of these assets allow us to do things that we could never do otherwise.
I see. All right. Thank you very much.
Next question, Evie Schwartz.
Hi, yes, not actually a question, just a comment. I think there's an assumption in this conversation as well that decommissioning only happens at the end of life. And there are definitely systems that are being decommissioned early, like at 7 years or so after the federal tax credit period. And so I just want to throw that out there. They're also, even without considering degradation for 20 to 30 years, even their systems being decommissioned after only 7 years. And the second comment was just, I think there's also an assumption that all the crews doing the decommissioning are specializing in PV only. And they're definitely like regular construction companies that are being hired who don't necessarily know how to handle the panels. And so that's also where one of the concerns about damage can come in.
Evie, the two, I didn't mean to, I hope I'm not creating, an impression that we're only talking at the end of 20, 25 years. In fact, I think there's a continuum. And there are brand new panels that are already available at Second Life. I'd really love to see numbers on what that looks like compared to, anecdotally, my feelings on it. So there's a continuum all the way from brand new too long term. And then, you know, as far as the labor, remember that we're using unskilled labor at 4 a.m. and we're trying to get very quickly onto trucks because we need to be out of there by 6 a.m. I feel like we're in one of the worst use case scenarios for decommissioning this stuff. And if we can get it done again and again, over and over for an entire year, then there must be a way to adapt what we're doing, albeit very expensively and not at the scale that y'all are talking about, to a larger use case. Or at very least, support the argument that decommissioning and reuse can be competitive. Robert Nicholson?
Yeah, I just wanted to reiterate that from the association's perspective, we are very focused on reuse, so much so that we are creating an ANSI standard for refurbishment and reuse that we would expect to publish in 2025. But our view is a much longer term view. We're looking at infrastructure that we need 40 years from now to make sure that, you know, in the process of improving the environment, we're not creating a completely different environmental issue with panels being stacked up someplace and not handled properly. The other thing I'll point out too is with reuse is the volumes. The reuse volumes won't match the volumes of panels coming out of the industry. So, you know, for a project that's got 2.5 million panels, 2.5 million panels may have some operating life left, but it gets harder and harder to find appropriate markets. So there's going to be cases where we have to enter into some resource recovery and recover that glass in those metals. So Neil, I love what you're doing. I love the whole story. I think from the association's perspective, we're looking at all of the above very intensely and expect to have that infrastructure together over the next couple of years.
I couldn't agree more. I definitely think that obviously, you know, there's a lot more that goes into what do you do after you decommission and try to if it's simply recycled. And I understand that too. I think with the limited visibility on the subject that I have, my main thing is to ensure that reuse is a strong part of this conversation. And I say that because only of my anecdotal experience in the field. When I go and talk to people in our industries, in the waste management industry and other industries, when I present at conferences and things, Robert, I don't hear people speaking about reuse nearly as much as the question comes up again and again: how much waste are we creating, and what are we going to get rid of? And you know, again, from a very from a very small perspective, what I don't want to see is the implementation of these technologies, which have, you know, I think Overdrive's growth trajectory just supports this, that a lot of these things are being, you know, a lot of these things are being held up, and this what's the word I'm looking for? This assumption that somehow dealing with end-of-life panels is burdensome and such is an impediment to efficient deployment. And of course, I'm a disruptor from a very, very disruptive field, so my perspective is going to be very different from all of you. But I do have firsthand, boots on the ground experience at how valuable these assets can be in a very small scale, in a very controlled environment. And you know, I want to do things that are going to support moving it forward in any way, understanding that timescales are very, very different in these worlds. And the last thing I'll say is that if we can support that by providing visible, highly, you know, data-driven use cases that show what repurposed panels can be doing in 20, 30, 40 years, then I think the music industry has done what we do well outside of performance. You know, we have a background in dealing with social issues and technological issues. I grew up with USA for Africa and things like that, and we can do this for climate change too. And we can do it with real results and real test cases.
This really reminds me of the, you know, EPA put out a kind of continuum for food waste or wasted food. And you have, getting that saleable product to, donated to homeless shelters, getting that highest use, and then goes to composting or anaerobic digestion. Then you go to like a co-digestion, then you go to landfill. So like looking at that whole continuum of maybe what's that next best use at that time for that product, making sure that we're prioritizing things in the right way certainly makes a lot of sense.
And let me just end by saying, I'm an engineer by trade. That's supposedly my background. But for the last 2-3 years, I've become more and more convinced that this is that a lot of the issues that we deal with in our jobs are actually dealing with culture. And having these effective examples of what we do helps all of us move forward. Because we know that panels aren't, like you said, the reality is PV isn't a dangerous, toxic thing. And frankly, we can keep going and talk about LFE batteries. We can talk about inverter technologies. So much of what we do with renewable energy systems is simply less dangerous. And of course, let's talk about, if we put it in the context of what we're doing right now with other technologies, they are among the cleanest, even long-term technologies. And when conversations happen, when these concerns come up, when this focus is on these things that are an impediment to moving them forward, I think we all lose an opportunity, and that's the biggest thing is that impediment.
Just a quick question. You mentioned growth potential. What are there other markets outside of concerts that Overdrive is looking at, or are there other markets that I guess you can see that where reuse can really be leveraged?
That is actually something that's Bradley, that's been expanding quickly. In what was it? Last week we had a meeting with an organization that is developing sustainable energy for remote agriculture, greenhouses, and things like that. And their focus is places where food production is underutilized because of power issues, whether it's developing countries, third world, rural areas in the United States, Native American reservations. There's a lot of different places where we simply need refrigeration, right? And second use panels lower the cost of that tremendously. We did some work with the U.S. Marine Corps Camp Pendleton, where they have their what is it called? Their amphibious vehicle testing station, which is in a nature preserve, right? They had assets, and they had the challenge of they want to get work done, but you all know what the procurement process is and everything. So how do we keep it under 10 grand so that they could get this through? And we use Second Life panels. It was easy, so that was kind of funny because again, tiny project, right? Just a bunch of engineers at Camp Pendleton trying to figure out how they can work on the beach. But Second Life panels played a role in that. There's a third one we just got exposure to, UNHCR project in Kenya about deploying panels again to remote medical clinics. And all these areas are places where the 5x cost reduction that we see for Second Life panels versus new panels at wholesale, I think can matter a lot.
All right.
How about last thing? Look at footprintproject.org if you get a chance, and remember that everything that they do is a donated Second Life or unused panel.
All right. Are there any other questions for any of the presenters? Okay, without further ado, David?
Thank you. One last question. Question is for Robert Nicholson. Did I understand you to say that SIA's position is that regional recycling plants are not needed? And I guess my question is that simply because you believe that the industry is already taking care of the issue, or is there another reason?
Yeah, the reason is twofold. It's one, we see acceptable growth in recycling capacity through private companies starting facilities, geographically across the U.S. We think if there's going to be a regional focus, it's more effective to focus on logistics, the collections side of the business, as new recyclers enter the market and become more competitive, bring better technology to market. But the real challenge is not necessarily processing the panels, it's collecting them, especially in smaller quantities. So from a regional perspective, we see the primary focus really should be collections.
My understanding is that most of the current systems don't get the lead or the silver out. And since lead is the major environmental issue that we're dealing with, what do we do if the commercial side of the industry doesn't capture the lead?
Well, what we're seeing right now from a recycling perspective, the companies that are entering the market now will send the metals, the lead, the copper, the silver, along to other companies, whether it's a smelting or a chemical recovery. There's more. I guess the point is, once the current recyclers finish the work that they do, the metals then go downstream to companies who are more focused specifically on those metals. So we're not seeing recycling companies today that receive the panels as a panel and then completely recover the precious metals as clean, specific precious metals. Typically, that material goes to another step, in some cases even outside of the U.S., for that precious metal recovery.
But isn't that part of the process required in order to go make the process cost effective?
Well, it could. That's an entirely different process. The metals recovery process is typically, again, it's either a thermal process or a chemical process, and requires volume. It requires scale. So if you're going to be a copper mill, as an example, there isn't going to be a solar panel recycler that is also a copper mill. There may be some copper mills that become solar panel recyclers, but it won't be the other way around. So typically, those panel recyclers would recover the laminate, for an example, that has the copper, the lead, the silver, and the silicon in it. They would then send that laminate to another facility that's specifically engaged in that type of metals recovery. Does that make sense, David?
I understand what you're saying. I'll talk to you offline about the rest.
Okay, sounds good.
Okay. So thank you for all of the presentations. I must say, they had me pretty amped up. And I'm seeing some head nods out in the audience. So, and some head shakes. So, just want to give folks a sense of what we're going to be talking about at our next meeting, and then we will open it up to the public. So we are going to have Bob Fadzinski with DNR going to be talking about the power plant research program. There's going to be a report that's coming out on that, and really talking about a review of decommissioning considerations for solar energy projects in Maryland. We're also going to have David Comas, who you've seen and heard, going to be reporting out on some projects that the master students at the university have been working on, and some of the findings that they've seen around solar recycling, reuse, different markets, and whatnot. And then, as I mentioned at the beginning of this, we're going to have someone from the EPA who's actually working on the new universal waste rule for solar panels. And they're going to be they have a super interesting model on projections, and what really helps us is those projections are done on a regional basis, so it can really help the state of Maryland with our own planning. Unless there's anything else, I would like to open it up to the public. If there's any questions, comments related to this working group.
Is it possible to get Bradley copies of the slides for today's presentation? We'd like to kind of go through those a little bit more.
Yeah, absolutely. And we will also be posting the slides on our website as well. And we're going to be
if you could provide a link to that, that would be good too.
Yeah. And then we'll also be having posting the recorded version as well. Oh, I think Shannon might have put it in.
That's a direct link to the primary working group page. So the meeting, if you scroll down to the bottom of the page, you'll see that the meeting materials, the agenda, work plan, introductory slides, etc., from the previous meeting are all there.
Could we include a link in the calendar invite just so that it's always there?
Oh yeah, we can do that.
Great.
We can also rename the calendar invite to be a little bit more inclusive.
There you go.
All right. Well, thank you everyone for joining us, and I think we're good to adjourn.
All right. Thank you, everybody.
Thank you all for having us. Bye-bye.
Thank you.
All right.
Thanks.
Bye.
Thanks.